Hey guys, welcome back to another video. In this video, we're going to be talking about a development process, really development process when it comes to making software or programs, anything that we want to do in computer science. We have to have some kind of process when it comes to developing what we want to create. So how does a program become a program? What does a program actually do when it runs on a computer? Um, Let's take a peek under the hood and examine the development process of how an idea gets turned into a dynamic, interactive program running on your computer. A development process can be ordered and intentional, or it can be exploratory in nature. And there's many different styles of development processes, but they all include these following phases: investigating and reflecting, designing, prototyping, and testing. So throughout computer science, you're going to use a development process that is iterative and incremental. What do I mean? A development process that is iterative requires refinement and revision based on feedback, testing, or reflection throughout the process. And this may require revisiting earlier phases of the process. A development process that is incremental breaks the problem down into smaller pieces and makes sure that each piece works before adding it to the whole. You can see here on this little graph here kind of how it's supposed to work. So each phase leads into the other phase, but it also is iterative in that it repeats. So it's a constant process of designing and or investigating, reflecting, designing, prototyping, testing. After the testing, we investigate and reflect more. We design more. We prototype more. So it continues. It's an iterative process. So let's talk for a minute about investigating and reflecting. So we want to take a look at each one of these phases. It all starts with an idea. Well, actually, it starts with a problem that necessitates a solution that then gives rise to the idea of how to solve the problem. Smart problem solvers begin the process of turning an idea into something real by first analyzing the problem at hand. They ask questions, they collect information, they gather data, they look at existing solutions, and they think through the situation as thoroughly as they can before diving into a solution. And it might seem difficult to restrain yourself when you're struck with a brilliant idea, but the best ideas are not always the first ones that come up. In practice, the first idea to come to your mind may be an inferior solution. With careful thought, consideration, and analysis of the idea's strength and weaknesses, a good designer can often come up with something better than their first instinct. So try to avoid knee-jerk reactions to initial ideas and keep looking for a better idea that might be out there. All right, let's talk about the designing phase. Once a developer has identified a solution that's worth pursuing, the next step is to create a well-specified plan of action. The design of a program incorporates investigation to determine its requirements. Investigation in a development process is useful for understanding and identifying the program constraints, as well as the concerns and interests of the people who are going to use the program. Here's some of the investigation methods that we could use. So we could collect data through surveys. We could have user testing. We could conduct interviews, or we could just do direct observations. The design phase should also outline how to accomplish a given program specification. A program specification defines the requirements for the program. It's extremely important for the programming team to understand what the program requirements are. Program requirements describe how a program functions, and it might include a description of user interactions that a program must provide. The program requirements are typically achieved through collaboration with the customer, who is the ultimate user of the program after all. Perhaps you may collaborate with a systems analyst and the software development team. Computer scientists, whether they're programmers writing code or designers developing algorithms, apply their computational thinking skills to mapping out a logical sequence of instructions that it's going to solve the problem. They recognize and use sequencing, selection, and iteration patterns. They anticipate and identify all of the unseen and unexpected complications that their solution will encounter. And they clearly define the requirements, expectations, and specifications for the resulting program's performance. The next phase is the prototyping phase. Once the program specifications have been clearly defined and all the algorithms have been constructed, programmers then implement the algorithm. That is, they actually write the code in an appropriate high-level or low-level programming language. These days, most software is developed in a high-level language, and that takes advantage of the benefits of abstraction to make the final code simpler and more straightforward for humans to understand, while still remaining formal and strict enough for a machine to read and parse. A wealth of development tools are available to help programmers more easily manage large programs that combine large numbers of smaller algorithms and operations. Both Scratch and Python provide an easy-to-use graphical interface with which to develop, test, and run your programs. So let's look at our last phase, and that is the testing phase. An incremental design process involves implementing a small portion of the algorithm in the programming language and then testing the code for correctness, efficiency, and error catching. And there's other aspects as well. Testing uses examples of possible user input, including incorrect user input, like typing a text string instead of inputting numeric values. The results may indicate a need to revisit earlier stages in the process, and thus the process is iterative in nature. Smart programmers also design thorough test cases to verify that all aspects of their program perform as intended. Sometimes the design of the algorithm is flawed, leading to a program that misperforms. Other times, the algorithm is sound, but the program fails to accurately implement it in the chosen programming language. Either way, it's important that these bugs or errors in the program are identified and corrected before the software is distributed to the users. The sum total of all of these discrete operations is what the end user recognizes as a properly functioning program, whether it's a web browser, a word processor, a video game, a streaming media player, or whatever problem it was that the original idea was intended to solve. Guys, thanks for watching this video with me today. I hope that it answered some of the questions when it comes to the processes that we use to develop programs. Anyway, y'all have a good day, and I will see y'all in the next video.